In this experiment, we toss 2 dice. We record the results, and then we keep track of the even faces from each dice roll. So if we roll 2 dice and we get 1, 1, for example, we would say there are no even faces because the 2 dice both had odd numbers. If we had a 1, 2, then we would say there's 1 even face because out of the 2 dice, one of them had an even number. Or maybe we get something like 4, 4, both even numbers. In that case, we would say there are 2 even faces. So our random variable x, which represents the number of faces that show an even number, can take on the values 0, 1, and 2. We can use those variable values to build a PDF table where we put in each of the variable values and find the probability of that outcome. So for 0 even faces, we can see that there's a total of 9 possible outcomes that would result in 0 even faces. So 9 out of 36 would be the probability. For 1 even face, we can see that there's a total of 18 possibilities that result in one of the 2 dice having an even face. So that probability is 18 out of 36. And then lastly, 2 even faces happens 9 times, so that probability is 9 out of 36. Now that we have our table, we should check and make sure it is a PDF. It is. All of our probabilities are between 0 and 1, and if we add our probabilities, we get exactly equal to 1. So this is definitely a probability distribution function. We can calculate the mean, or the expected value of the PDF, by multiplying each of the variable values to the corresponding probability. So the variable value 0 times its probability, 9 out of 36, gives us a 0. And we repeat this for the x value 1 and the x value 2. Now that we have these products, we can add them together. That sum is our expected value. We use mu to denote the expected value, or the mean, so we have mu equals to 1 for this experiment. If we roll 2 dice many, many times, on average, we expect one of the faces to be an even number. Now let's take a look at the standard deviation. So trying to calculate how far away each of the variable values is from the mean. We're going to build this piece by piece using a table. First, we're going to find the deviation from the mean for each of the variable values. We'll make a new column on our table for the deviations, and we know that mu is 1 since we just calculated it, so we're really just finding x minus 1 for each of the x values. After we have the deviations, we would like to square the deviations. That way we can get rid of the negative values. We'll square each of our deviations. And then next we're going to multiply each square deviation to the corresponding probability for that variable value. We'll make a new column for this. We'll take each square deviation and multiply it to the appropriate probability for that variable value. So for x equals 0, we're multiplying 9 out of 36 times 1. For x equals 1, we're multiplying 18 out of 36 times 0. And for x equals 2, we're multiplying 9 out of 36 times 1. These products need to be added together before we can square root them to find our standard deviation. The sum of these products is 18 out of 36. Finally, we can take the square root of that sum to find our standard deviation sigma. So the square root of 18 out of 36 is about 0.7071. So that is our standard deviation.